A quick announcement before the presentation. We will be having an AOSP BOF in the evening at around 4:30. So if you have any questions around GBL or 16K page size or anything around AOSP, please do come and join us in that. Right, so welcome to another session on GBL. Ram and Paul have already covered the fundamentals of GBL and its enablement and usage from cuttlefish point of view in the earlier session. In this session, I'll be talking about the enablement of GBL on Linaro supported development boards, the how-tos and the challenges. My name is Amit Pundir. I'm a senior engineer in Linaro. I have 10 plus years of experience in I have 10 plus years of experience on ASP bring up and maintenance. You can find me on these IRC channels. Right, so in this session, I'll be talking about the Android bootloaders and GBL. Ram and Paul have already covered most of it in the previous session. So I'll keep it brief and move on to the main topic of this session, which is about enabling GBL on Linaro supported development boards. I'll start with a short rant on forever changing Android bootloader requirements in almost every Android release. And as Ram has also pointed out in his previous presentation, that is the main reason why we are having this session. And that is the main reason why the vendors and the platform enablers need GBL. So let's have a quick look at the Android bootloader fragmentation problem. Unlike Linux kernel, there is no consensus on a common bootloader among Android vendors. So each vendor implemented Android bootloader features in their respective bootloader. And in the worst case, they maintain different versions of bootloader for the same SoC running different Android versions. Meanwhile, these vendor implementations add little to no value in the differentiation of Android functionality. And as we saw again in the earlier presentation, GBL plans to fix this Android bootloader fragmentation. It provides a hardware agnostic interface that abstracts the vendor's platform-specific bootloader implementation, thereby reducing the vendor's burden or overhead and resulting in faster uptake of Android boot changes. In the next set of slides, we'll talk about enabling GBL on Linaro-supported development boards. But before, let's take a small look at the state of stock bootloaders on development boards. In my opinion, the state of bootloaders on development boards is worse than the Android bootloader fragmentation problem, because at least on Android devices, you will get some kind of updates from the vendor. On the bootloaders, you get what you have on your device. We are lucky on Qualcomm dev boards that we get reference bootloader implementations on Code Linaro. And in the past, cherry picking the relevant features from newer releases have worked fine for us, but the process is tedious and error prone. And again, as I mentioned, that unlike high volume commercial devices, bootloader updates on dev boards are very rare and almost non-existent. Meanwhile, on other vendor dev boards, a reasonable way out is to adopt or switch to other bootloader alternatives like uBoot or coreboot if possible. Or do better and switch to GBL. So the last slide is exactly the reason why we are so excited about GBL on our dev boards. No more vendor lock-in, no more waiting on vendor implementation. GBL provides vendor-independent bootloader features and can be updated independent of vendor interference. Right, so I'll come to the implementation part of how to start enabling and using GBL on your devices. To enable or make use of GBL on your devices, your stock bootloader, your inherent bootloader should support UEFI app loading. The choice to switch to uBoot for GBL was easier for us. Most of our dev boards already have some kind of uBoot support enabled or work in progress, thanks to Qualcomm lending team. GBL is developed and tested with uBoot internally in Google, so win-win for us. And finally, our in-house uBoot expertise that we can make use of it if we run into any kind of uBoot issues or if we get stuck. In the following set of slides, I'll share the relevant steps to build, flash, and boot the uBoot, the GBL, and AOSP on dev boards. The detailed set of instructions and how-tos to enable GBL on RB3, RB5, SM8550, HDK, and E85096 soon are hosted on devboards for Android portal. So these instructions are just short snippet of that. So we start with building uBoot with EFI loader support, and then we build GBL. Right. Then we build AOSP. So the GBL port which we had currently running, it's in a very stable version. So it's at a very stable state. So we did not want to switch to a newer development snapshot of GBL. So we are sticking to what we already have working. And at that time, it was only supporting boot image header version 4 with init boot partition as mandatory boot partition. So we had to enable those options in our AOSP build. We have to disable the verity bits because we don't do that. So we have to prepare a dummy VB meta image. Now we have to flash the custom GBL and AOSP images onto that device. So for this experiment, we don't have access to the partition table on few of our dev boards. So we realized that it is easier to use external storage like MMC SD card and do all these experiments. So the uBoot support for all the MMC SD card support for that particular SoC were already present. So we can just enable that, flash the custom partition to the GPT layout which we wanted, and yeah, that pretty much did the trick for us. The only thing is that at some point we got stuck because the fastboot was not able to figure out the MMC device, and turned out there was a def config available in the uBoot configuration that you had to change. Again, the detailed instructions are hosted on devboards for Android project. Next part was booting the AOSP using GBL. Standard set of instructions. You copy it, load it, and run the boot EFI commands. This is just a small snapshot of what you will see on the screen on your dev board. And this is how the GBL boot flow looks like on your dev board. You start with the ABL. Everything we are just chain loading from one stage to another one, right? So we have the ABL, the stock bootloader. We do fast boot, uBoot. The uBoot starts. We have already scripts defined. All the boot flows already defined in the uBoot, and uBoot will chain load the GBL, and GBL will do all the verifications, AVB bits, and it will load the AOSP. Right, to summarize this session, we learned how GPL helps in fixing our bootloader issues, the bootloader fragmentation issues, and how it helps platform developers deliver the faster Android upgrades. Enabling it on dev boards bridges the gap between the production and the prototypes which we have, and it enables the testing of Android boot flow with automated testing and CI. couple of references from the past LPC where we have talked about the same issues before the GBL started. And so I had this this bonus slide here. So Ram talked about the custom EFI protocols that need to be implemented in your stock bootloader, be it UEFI, uBoot, or little kernel. One of the protocols is the fastboot over USB. Fastboot is something which is like when you talk about Android, you talk about ADB and fastboot. I mean, if you talk to an Android developer, right? So this is one custom protocol which thought that we needed that, and luckily, since as I mentioned earlier in the slides, uh, GBL development inside Google happens on uBoot. So we were lucky to find a downstream uBoot implementation which had this particular protocol implemented. So we could just cherry pick it and do some rebasing on the later version of uBoot versions, and we got it working. And that's the end of my slide set. If you have any questions, I'm happy to help.
For replicating what you've just mentioned, this is all on devboards, the devboards website, and all those scripts and whatnot.
Yes, everything is there. Yeah, all the instructions and everything.
In terms of what you're doing next with it, is there like, do you have other devboards you're planning to bring up? Like, are you going to add other GBL features?
So the next step was deploying it in the lab. Did I skip that slide? I'm so sorry. Oh, I think I skipped that slide. So the next step is to enable AOSP booting. So the AOSP boot flow with GBL in our testing lab, because it helps us to move few of our devices from boot image header version 3 or even 2 to 4. And that's what we aim to do that. And that's why we like GBL, because we don't have to worry about the vendor implementation, because that is locked and we cannot do anything there. But if you switch to GBL, you make use of the user space fastboot daemon. We can make use of boot image header version 4s. We can make use of the whatever you are landing in the next 2 months.
So whatever protocols are there, OS configuration, everything you have implemented in uBoot as of now?
So from the UEFI point of view, we only picked up the fastboot one.
Okay. So whatever ABL is currently doing, that will still be there in the picture, like your ddfix boot config.
So ABL hands over the control to uBoot.
At like what point, like you're replacing the loading of kernel with
So we're replacing the boot image.
Okay, with uBoot.
With uBoot.
Okay, so whatever we were doing initially with the DTV, that is still happening in ABL itself?
That is still happening in the ABL.
Okay, so only fastboot is what you're handling here. So when you move from uBoot, what all protocol implementation do you have currently in uBoot that you are utilizing for GBL?
Only the fastboot.
Only the fastboot.
Yeah. And from the GBL point of view. Right. And there is a list of EFI protocols which you want to take this one.
So extra context is you can boot GBL on any UEFI implementation without any of the Android configs, and it will boot unverified. It'll just say it's very broken, and the production flow won't allow that.
So whatever AVB flow, everything is there, that will not come into the picture?
It'll just note that it's not allowed, or note that it's not implemented in the logs, and then just continue.
And OS configuration, everything will just bypass?
Yeah. It'll choose defaults for everything that's not provided.
Oh, understood. Thanks.
Thank you very much for joining me in this session.